Today's lesson is about conditional probability. So like with the previous two lessons, there's a Dr. Nick video which you'll need to watch first. So if you haven't done that already, you need to go back, watch that video, and then come back to this video so you can understand the questions. Just summarizing what was said in Dr. Nick's video, is that conditional probability is the probability of one event, and it will depend on whether or not another event has occurred. So the example we've got is that there are 2 red and 3 blue counters in a bag. Without looking, we take out one counter and we do not replace it. So the probability of the second counter taken from the bag depends on whether the first was blue or red. Conditional probability problems can be solved by considering the individual possibilities of using a table, a Venn diagram, a tree diagram, or a formula. So with a lot of these questions, you can solve them in any number of different ways using these different methods. There's no one right way or wrong way. In some cases, it is worth knowing more than one though, because in a lot of cases, there's one way that is a bit more straightforward, where the other ways take a bit more of playing around. Harder problems are most easily solved by the formula together with the tree diagram. Okay, so just a little bit of notation. Obviously, PA means that the probability A event occurs. What we've got now is the probability of A given B. So that's vertical line means given, or is the conditional probability. So the probability A occurs given B. So it's in order, you say it from order left to right. So it can get confusing on which one's the condition and which one is the event we're interested in. And also we've talked about the complement of A. So here is our question. The following table gives data of a type of car grouped by petrol consumption, so low, medium or high, and owned by 100 people, which is split into gender, male or female. So with all these tables, first thing is make sure we get the totals. Oh, no, we don't need the totals. One person is selected at random. L is the event that the person owns a car and is low rated. And F is that the event a female is chosen. So we've got 3 questions here. The first question is the probability of L, which is the probability of getting a low consumption car if we select at random. The next one is the probability of getting a female and a low consumption car. And lastly, the probability of selecting a female given it's a low consumption car. So again, the language with this is really important. So you need to make sure when you're using the right language with the right symbols and with the right type of question. Because we've got the table, there's no need to do a Venn diagram or a formula to solve this type of problem. We need to be careful which row and column we look at. So starting with the probability of L, or probability of a low consumption car, the first thing we need to do is work out how many low consumption cars there are in total. 35. So that means that it's 35 cars out of a total of 100. A nice straightforward one. Part 2. Sorry, that was just stating that normally keep them as fractions, as sometimes they don't make exact decimals. It is good practice to simplify, but it's not necessary. So 7/20. So part 2, we've got the probability of selecting a female, and they have a low consumption car. So that's 23 So 23 females have a low consumption Ca, and then that is out of 100. So the last one, and again, think about the language, probability that you select a female given they have a low consumption Ca. So we know that there are 23 females that have a low consumption Ca. What's different about this question is that given part. It's almost like the low consumption Ca has been selected, so we selected the low consumption Cars only and then took the 23 hours with them. So rather than it being out of 100, is that we actually say it's out of 35. Now, what we should notice that if you actually multiply this number and this number together, what you end up getting is you get this number. And that's not surprising really, because we've got the probability of a low consumption car from the group of having females and low consumption cars should equal that other value. You don't need to worry about that too much, apart from the fact that this formula works. So the key thing for this lesson is that this is the formula. It's the one given to you in the exam, that if you know something is, you know those values, you can, or two of those values, you can work out the third. So here's another problem. I have 2 packets of seeds. One contains 20 seeds. Although they look the same, 8 will give me red flowers, 12 will give me blue. Second packet gives me 25 seeds, which will end up with 15 red and 10 blue. So we need to draw the Venn diagram. So again, we need to be careful with the events. It's very tempting to do 2 circles and say one's red, one's blue. In this case, it's one is red. Sorry, one of the circles is either whether it's red or not. So not red is obviously blue, and whether it came from the first packet or not, which is the second packet. So we end up with our Venn diagram here. So blue is simply the complement of red, and for the second packet, that's the complement of the first packet. Right? Sometimes it's easier to narrow it down and not worry about it. Think about in terms of the complement rather than actually what they are. So obviously this region is the red in the first packet, so that we're going to put 8 in there. Right, the next one is blue from the first packet, so we're going to put 12 in there. So now red from the second packet, which we know is 15, and we know that there are 10 blues from the second packet, which must be outside. So we end up with a total number of seeds, 45, and that all works. Now looking at some questions. The probability of getting a red and getting a red and from the first packet is just simply 8 out of 45. Now the probability of getting red, given they're from the first packet, is out of 20, because there are 20 seeds in the first packet. So that's the condition. The condition was that you selected from the first packet. That's why it comes out of 20, and there's 8 of those. Now the other thing is probability that they've come out of the first packet is going to be 20 out of 45. Now thinking back to the formula, if I take those 2 values, the probability red given F, or given the first packet, times the probability they're in the first packet, cancel it down, we end up with 8 out of 45. So we end up with what we started. So again, that's proving that formula and how it works. So the key things to take out of this lesson is that we've got this formula. It can also be, and this is the way it is presented in the exam or on the formula sheet. It's shown this way, but you can rearrange it so that it looks like that. And obviously we can use the intersection sign. I'll show you one more example of using a tree diagram and conditional probability. So here in November, the probability of a man getting to work on time if there's fog is 2/5 on the M6. The M6 is a motorway that goes north to south through England. It goes through Oxfordshire all the way up to Manchester, I think. If the visibility is good, the probability is 9 out of 10. If the probability of fog at the time he travels is 3 out of 20. Firstly, calculate the probability of him arriving on time. Second, calculate the probability that there is fog given he arrives on time. So there's lots of clues in the question that tells us that we're dealing with conditional probability. The key one that I would identify with is given. But the fact that if there's fog, if the visibility is good, and the given he arrives on time. So there are things where the probability changes depending on what the conditions are. So we're going to say that there's 2 events. First of all, that he gets on work on time. Second one, that there's fog on the M6. So so these are the things we're trying to work out. So the probability of a man getting to work on time. So given that there's fog, that he's on time is 2 out of 5. Visibility is good, so meaning no fog, the probability is 9. So you can see that we've got the complement of F there. The probability of fog at the time he travels is 3 out of 20, so probability F 20. So because it's a bit more difficult to put together, a tree diagram's the way to go. So first of all, we've got 2 outcomes. That's whether there's fog, which is 3 out of 20. No fog, because they have to add up to 1, should be 17 out of 20. So after that, it's whether he gets to work on time or not. On time, so we know given, so matching up, given it's foggy, he's on time 2/5. The time, not on time, must add up to 1, so 3/5. Now with this branch, it's either on time, again, that must go there because this matches that. So given it's not foggy, he's on time 9/10 of the time. And now we've got our probability tree. We can just multiply along the branches. And then, so once we've multiplied branches, we can see all of the only, we can work out our probabilities if we need to. So the probabilities of him arriving on time must be that branch. it's foggy and he arrives on time, or it's not foggy and he arrives on time. And we can add those together and we end up with 165 out of 200, which simplifies 33 over 40. Probability that there was fog given that he arrives on time. Now, in this case, we have to use the formula. So we know the probability of foggy and on time. We know it's 6 out of 100. And we know the probability of being on time is 33 out of 40. So we can divide those and we end up getting 4 out of 55. Okay, so there's quite a lot to that question. Go back and have a look at it again. But if you break it down into smaller parts, it should be a lot easier. Here's an exercise which I'd like you to have a go at now. So pause the video, copy the table down and have a go at the following questions. So we've got people being asked how they travel to work, then split to male and female. So work out the probability if you chose someone at random, they were male, probability that given they have a car, or they take a car to work, that they're male, and the other one is that they're not male and they have a car. And lastly, given they're not male, in other words female, what's the probability they have a car? So pause the video and then we'll review the answer. Okay, so we've got 54 out of 100 for the probability they're male. Given they've got a car and they're male, so it's 26 out of 43. Female and a car, it's obviously 17 out of 100 because there's no condition. And given that they're not male, so female, or the complement to male, is 17 out of 46. So this question about the Wimbledon Tennis Championship, it requires you to do a tree diagram. So have a go at answering the questions. So just pause the video and then we'll go through the answers. Okay, hopefully you had a go at that and you managed to get some answers. So let's have a look. So first thing is the two events, temperature will be 28 or more, or whether the player wins or not. So the probability of it being more than 28 or more is 3/8. The probability given it's under, that the player wins under 28 degrees is 3/4. Given that the temperature is over 28 or over, that the player wins is 1/2. So they have a better chance of winning if the temperature is below 28. So presenting our tree, we can get the following numbers and then we go through and find the individual probabilities. So they should add up to 1 and they do. So now that we've got that, we can work out the probability of winning, of the player winning, is those two branches together, which gives us 21 over 32. Second part of the question is looking at the probability of the temperature being over 28 if the player wins, given that the player won. So the probability is the temperature is over 28 and the player wins is that top branch, which is 3/16, divided by the value we got in the previous part, which is 21 over 32, which gives us our final answer of 2/7. Okay, so so that's conditional probability. There's a worksheet for you to complete on the lesson page, so do that now.